So in order to determine the distance from the origin of a given point, keep in mind that, pretend that's an actual Cartesian coordinate plane, that when you combine the x value and the y value of a given point, you're actually creating a right triangle. And so the distance from the origin is actually the hypotenuse of a right triangle, and so the distance is equal to the square root of the x value squared plus the y value squared, because a squared plus b squared equals c squared. So basically, if we can get the x value and the y value of the 2 points, or find out that the x and the y values are the same without getting the actual numbers, we can determine that they have the same distance from the origin. Statement 1 tells us that the absolute value of p equals the absolute value of q. Those are the x values of the 2 points. But without the y values, no r and no s, there's no way that this statement could be sufficient. Whoops. S is the opposite of what we want here. Insufficient. We get rid of choice A and D. Statement 2, likewise, we have 3 of the 4 coordinates, Q, R, and S, but without P, we can't determine sufficiency. So statement 2 is also insufficient on its own. So in conjunction, we do find out that the absolute value of P is equal to the absolute value of Q, and that's equal to the absolute value of R, and that's equal to the absolute value of S. So basically, the distance of each of the points, it's just going to be the absolute. All of these are going to be positive numbers. They're all going to be the exact same number, and so so it might be 1 1 1 1 or 3 3 3 3. It doesn't really matter. They're guaranteed to all have the same distance from the origin. So in conjunction, the two statements are sufficient.